If a ground fault circuit interrupter receptacle is not resetting after being tripped, it could indicate a real problem. There are several possible causes. Firstly, a faulty ground fault circuit interrupter receptacle. The receptacle may have failed or may have been installed incorrectly. Secondly, an overloaded circuit. If the circuit connected to the ground fault circuit interrupter receptacle is overloaded, it may have caused the receptacle to trip. Thirdly, loose connections. Loose connections in the electrical circuit can cause intermittent power outages and prevent the ground fault circuit interrupter from resetting. Here are steps to troubleshoot the issue. 1. Check the circuit breaker panel. Ensure that the circuit breaker associated with the ground fault circuit interrupter receptacle has not tripped. If it has, reset the breaker and attempt to reset the ground fault circuit interrupter again. 2. Inspect the ground fault circuit interrupter receptacle. Look for any visible damage or loose connections. Make sure the wires are securely fastened to the terminals and that the faceplate is properly installed. 3. Test the circuit. Use a multimeter to verify that the circuit is receiving power. If there is no power, check for loose connections or a blown fuse. 4. Contact an electrician. If you are unable to identify and fix the issue, it is recommended to contact a qualified electrician for further diagnosis and repair. Let's discuss a 60 amp service. A 60 amp service is relatively low for a modern home. If the circuit is overloaded, it may cause the breaker to trip regularly. Consider having an electrician inspect the electrical system and upgrade to a higher amperage service if necessary. When a ground fault circuit interrupter, or GFCI receptacle trips, it's designed to protect you from electrical shock. However, when it refuses to reset after tripping, it signals an underlying problem that needs attention. Let's delve deeper into the troubleshooting steps. Begin by thoroughly examining the circuit breaker panel. Locate the breaker that corresponds to the affected GFCI receptacle. If the breaker is in the tripped position, which is usually a middle position between on and off, reset it by first switching it fully off and then back on. After resetting the breaker, attempt to reset the GFCI receptacle by pressing the reset button on the receptacle itself. If the GFCI still doesn't reset, move on to the next step. Carefully inspect the GFCI receptacle for any visible signs of damage, such as cracks, burns, or loose wiring. Pay close attention to the connections on the back of the receptacle. Ensure that all wires are securely fastened to their respective terminals. Loose connections can cause intermittent power interruptions and prevent the GFCI from resetting. If you find any loose wires, tighten them using a screwdriver, but be careful not to over-tighten and strip the screws. After checking the connections, make sure the faceplate is properly installed and not pressing against any of the internal components of the receptacle. If the GFCI receptacle still doesn't reset after checking the breaker and inspecting the receptacle, you'll need to test the circuit to verify that it's receiving power. Use a multimeter to measure the voltage at the receptacle. Set the multimeter to the appropriate alternating current voltage range, typically 120 volts. Place the multimeter probes on the line and neutral terminals of the receptacle. If the multimeter reads approximately 120 volts, then the circuit is receiving power. However, if the multimeter reads 0 volts or significantly low voltage, then there is a problem with the circuit. If there is no power at the receptacle, check for loose connections further upstream in the circuit, such as at other receptacles or light fixtures. Also, check for any blown fuses in the fuse box or trip breakers in the circuit breaker panel. If you are unable to identify and fix the issue yourself, it's best to contact a qualified electrician for further diagnosis and repair. Electricians have the expertise and tools to safely and effectively troubleshoot electrical problems. They can identify the root cause of the problem and recommend the appropriate solution. Now let's discuss the implications of having a 60 amp service in a modern home. A 60 amp service is relatively low for a modern home, which typically requires a higher amperage service to meet the demands of modern appliances and electronics. If the circuit is overloaded, it may cause the breaker to trip regularly, which can be inconvenient and potentially dangerous. Consider having an electrician inspect the electrical system and upgrade to a higher amperage service if necessary. Upgrading to a higher amperage service will provide more power to your home and reduce the risk of overloading the circuit. The electrical service is the main electrical supply to a building. It consists of the service entrance conductors, metering equipment, and main disconnect. The amperage rating of the service determines the total amount of electrical power that can be safely used in the building at any given time. A 60 amp service is typically found in older homes or small apartments. It may be sufficient for basic electrical needs, such as lighting, small appliances, and a few electronic devices. However, it may not be adequate for modern homes with multiple large appliances, such as air conditioners, electric stoves, and clothes dryers. If the electrical service is too small, it can lead to several problems, including overloaded circuits, trip breakers, and flickering lights. In severe cases, it can even cause a fire. It's important to ensure that the electrical service is adequate for the electrical needs of the building. If you are unsure whether your electrical service is adequate, consult with a qualified electrician. They can assess your electrical needs and recommend the appropriate size service. Upgrading an electrical service is a major undertaking that should only be performed by a qualified electrician. It involves replacing the service entrance conductors, metering equipment, and main disconnect. It may also require upgrading the electrical panel and grounding system. The cost of upgrading an electrical service can vary depending on the size of the service, the complexity of the installation, and the local labor rates. However, it's an investment that can improve the safety and reliability of your electrical system. In addition to upgrading the electrical service, it's also important to ensure that the electrical wiring in the building is in good condition. Older wiring may be outdated and not able to handle the demands of modern appliances and electronics. If the wiring is damaged or deteriorated, it should be replaced. Replacing electrical wiring is another major undertaking that should only be performed by a qualified electrician. It involves removing the old wiring and installing new wiring. It may also require upgrading the electrical outlets and switches. The cost of replacing electrical wiring can vary depending on the size of the building, the complexity of the wiring, and the local labor rates. However, it's an investment that can improve the safety and reliability of your electrical system. When dealing with electrical issues, safety should always be the top priority. Never attempt to work on electrical wiring or equipment if you are not qualified and comfortable doing so. Always turn off the power at the circuit breaker before working on any electrical wiring or equipment. Use insulated tools and wear appropriate safety gear, such as rubber gloves and safety glasses. If you are unsure about anything, consult with a qualified electrician. Understanding the basics of electrical systems can help you troubleshoot common problems and ensure the safety of your home. Remember to always prioritize safety and consult with a qualified electrician when in doubt. Electrical safety is crucial. Electricity can be dangerous, even deadly, if not handled properly. That's why it's so important to take precautions when working with electrical wiring or equipment. Always turn off the power at the circuit breaker before working on any electrical wiring or equipment. This will prevent you from getting an electric shock. Use insulated tools, such as insulated pliers and screwdrivers. Insulated tools will protect you from electric shock if you accidentally touch a live wire. Wear appropriate safety gear, such as rubber gloves and safety glasses. Rubber gloves will protect you from electric shock, and safety glasses will protect your eyes from flying debris. Never work on electrical wiring or equipment in wet or damp conditions. Water is a good conductor of electricity, so you are more likely to get an electric shock if you are working in wet or damp conditions. If you are unsure about anything, consult with a qualified electrician. A qualified electrician has the knowledge and experience to safely work with electrical wiring and equipment. Here are some additional tips for electrical safety. Don't overload electrical outlets or circuits. Overloading can cause the wires to overheat and start a fire. Use extension cords safely. Don't run extension cords under rugs or furniture, and don't use them for long periods of time. Keep electrical cords away from heat and water. Heat can damage electrical cords, and water can cause them to short circuit. Inspect electrical cords regularly for damage. If you find any damage, replace the cord immediately. Have your electrical system inspected regularly by a qualified electrician. An electrical inspection can identify potential problems before they cause a fire or other safety hazard. By following these safety tips, you can help prevent electrical accidents and keep your home safe. Remember, electrical safety is everyone's responsibility. Regarding ground fault circuit interrupters, these are safety devices that protect you from electric shock. They work by monitoring the flow of electricity in a circuit. If the flow of electricity changes suddenly, the ground fault circuit interrupter will trip, cutting off the power to the circuit. Ground fault circuit interrupters are required in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor outlets. It's important to test ground fault circuit interrupters regularly to make sure they are working properly. To test a ground fault circuit interrupter, simply press the test button on the receptacle. The ground fault circuit interrupter should trip, cutting off the power to the circuit. If the ground fault circuit interrupter does not trip, it needs to be replaced. Ground fault circuit interrupters are an important safety device that can protect you from electric shock. Make sure you have them installed in your home and that you test them regularly. Electrical panels, also called breaker boxes, are the central hub of your home's electrical system. They distribute electricity to different circuits throughout your house. Electrical panels contain circuit breakers, which are safety devices that protect your home from electrical overloads. When a circuit is overloaded, the circuit breaker will trip, cutting off the power to the circuit. It's important to know how to reset a circuit breaker. To reset a circuit breaker, simply flip the switch to the off position and then back to the on position. If the circuit breaker trips again, there is a problem with the circuit that needs to be addressed. Electrical panels should be inspected regularly by a qualified electrician. An electrical inspection can identify potential problems before they cause a fire or other safety hazard. Electrical wiring is the network of wires that carries electricity throughout your home. Electrical wiring should be installed by a qualified electrician. Electrical wiring should be inspected regularly for damage. If you find any damage, it should be repaired immediately. Damaged electrical wiring can cause a fire or other safety hazard. Electrical outlets are the points where you plug in electrical devices. The electrical outlet should be installed by a qualified electrician. Electrical outlets should be inspected regularly for damage. If you find any damage, it should be repaired immediately. Damaged electrical outlets can cause a fire or other safety hazard. Light fixtures are devices that provide light. Light fixtures should be installed by a qualified electrician. Light fixtures should be inspected regularly for damage. If you find any damage, it should be repaired immediately. Damaged light fixtures can cause a fire or other safety hazard. Appliances are devices that use electricity to perform a task. Appliances should be used safely. Follow the manufacturer's instructions when using appliances. Don't overload electrical outlets or circuits with appliances. Keep appliances away from water. Inspect appliances regularly for damage. If you find any damage, have the appliance repaired by a qualified technician. Extension cords are used to extend the reach of electrical cords. Extension cords should be used safely. Don't overload extension cords. Use the correct size extension cord for the appliance you are using. Don't run extension cords under rugs or furniture. Keep extension cords away from water. Inspect extension cords regularly for damage. If you find any damage, replace the extension cord immediately. Surge protectors are devices that protect electrical devices from power surges. Power surges can damage electrical devices. Surge protectors should be used with sensitive electronic equipment, such as computers and televisions. Surge protectors should be replaced every few years. Grounding is a safety feature that protects you from electric shock. Grounding provides a path for electricity to flow safely back to the electrical panel in the event of a short circuit. All electrical outlets and appliances should be properly grounded. If you are unsure whether your electrical system is properly grounded, consult with a qualified electrician. Aluminum wiring was used in some homes built in the 1960s and 1970s. Aluminum wiring is more likely to cause a fire than copper wiring. If you have aluminum wiring in your home, it should be inspected by a qualified electrician. The electrician may recommend replacing the aluminum wiring with copper wiring. Arc fault circuit interrupters are safety devices that protect your home from electrical fires. Arc fault circuit interrupters detect arc faults, which are dangerous electrical conditions that can cause a fire. Arc fault circuit interrupters are required in new homes and in some renovations. If you are building a new home or renovating an existing home, be sure to install arc fault circuit interrupters. Electrical permits are required for some electrical work. Check with your local building department to see if you need an electrical permit for the work you are planning to do. Electrical inspections are required for some electrical work. Check with your local building department to see if you need an electrical inspection for the work you are planning to do. Hiring a qualified electrician is important for any electrical work. A qualified electrician has the knowledge and experience to safely and properly perform electrical work. A qualified electrician will also be able to obtain the necessary permits and inspections. Before hiring an electrician, be sure to check their license and insurance. Also, get a written estimate for the work before it is started. When choosing an electrician, consider their experience, qualifications, and reputation. Get referrals from friends or family members. Read online reviews of electricians in your area. Once you have chosen an electrician, be sure to get a written contract that outlines the scope of the work, the cost, and the payment schedule. Electrical codes are a set of rules that govern the safe installation and maintenance of electrical systems. Electrical codes are designed to protect people and property from electrical hazards. Electrical codes are enforced by local building departments. It's important to be familiar with the electrical codes in your area. You can find the electrical codes for your area on the website of your local building department. Electrical safety is everyone's responsibility. By following these safety tips, you can help prevent electrical accidents and keep your home safe. Always remember to prioritize safety and consult with a qualified electrician when in doubt.